Let's look at this problem. A certain TV show recently had a share of 80, meaning that among the TV sets in use, 80% were tuned into the show. Assume that an advertiser wants to verify the 80% share values by conducting its own survey. And the pilot survey begins with 12 households having TV sets in use at the same time of the TV show broadcast. So they want us to answer the first question: find the probability that all of the households are tuned in to the TV show. So in general, when we're doing a binomial distribution, we have the number of trials. N is going to be the number of trials. In this case, there's 12. And then for each of those, there's an 80% chance that they would be tuned into the show. Now, X is what they call the number of successes. And so what they're asking for in part A is the probability that all of the households, there's 12 of them, they want to find the probability that all 12 of them are tuned in. And so the probability would be letting X equal to 12. So the binomial probabilities are set up so that you have X, the number of successes, are either 0, 1, 2, 3, all the way up to N. So if there's 12 of them, there's a probability that nobody's tuned in, 0. There's a probability that only one of them is tuned in. There's a probability that 10 of them are tuned in, or 11. And there's a probability that 12 out of 12 are tuned in. So that's all of them. So each of these values for X has its own probability. And I'm going to do this in a spreadsheet where there's a special command. I'll put equals, and the command is binom distribution, or DIST, binom dist. And then they want the number of successes. And the number of successes will change as I do this. So I'm going to click on 0 there, comma. The number of trials is 12, so I'll put 12. And then the probability for success is 80%, so that's 0.8. And then I want to know if they're asking if it's cumulative or not. So in this case, it's not cumulative. You don't have to worry about this this command because we're going to do this in our graphing calculator. But anyways, this is the value for X is equal to 0. So if you ran this experiment, and if I asked you what is the probability that none of them would be watching TV, then this is your probability, which is really, really small. Now the reason I use Excel is that I can assign a value for the number of successes, which is A3 in this case. But then if I click and drag, I'm going to get the number of successes for different values. So for example, the number of successes for 11, if there was 11 successes out of 12, the probability would be 0.206. And then if there was all of them, all 12 of them, the probability would be 0.0687. Okay, so that's how they get that. Now on the calculator, the order is a little bit different. So in the calculator, you would type binom PDF N and then P and then X. So if you take out your calculator, binom PDF is under distributions, DISTR. So I'll press second function and vars. And then I have a bunch of distributions to choose from. In this case, you're going to choose binom PDF. Now there's PDF and CDF, so you want to choose PDF for this first one. Depending on your calculator, you can either put in the values or you can type it in here. So the number of trials was N. There's 12 of them. And then the probability is 0.8. And then the X value that I want for the first one is 12. That's all of them. And then, so this particular version of the calculator allows me to use this special screen to fill in the formula. So binom PDF 12.8 and then 12. So if I press enter, you should see that I should get the same value that I got from my Excel file, which is 0.0687. So that is the first one. That's the answer for the first one. The probability that everybody's tuned in is 0.069 is what they say, but that they rounded off to 3 decimal places. The second question is find the probability that exactly 12 households are tuned in. I mean exactly 11, sorry. Find the probability that exactly 11 households are tuned in. Well, that's just the P of 11 in this case, which is 0.206. Again, in the graphing calculator. Let me change my calculator here. So now my calculator has the traditional settings. So if I go second, distributions, and then I go look for the binom PDF. One more time. So if I go to distributions and look for binom PDF, and then here I don't have that regular the other screen, the more advanced screen. I just have to type in my N, which is 12, and then my P, which is 0.8, and then this time my other value is 11. So that should give me the 0.206. Okay. All right. Now the next question, find the probability that at least 12 households are tuned in. That means 12 or higher. So we would be interested in looking at, looking at the values for anything that's higher than 11, at least 11. So what we would do is we would add up the two probabilities that are past 11, and it's quite possible that there would be more probabilities if this thing went all the way up to 20 or something, and then they would have more things to add. Now adding two numbers isn't bad, but when you're adding more numbers it gets a little bit crazy. So in that case you probably want to do a cumulative distribution. So let's first add these two numbers to see what we actually get. And I'll just do the addition by Excel, and the answer looks like it's going to be 0.2748. That's 0.275 is the answer that you got. But in the graphing calculator, what we can do is we can calculate all these values. There's a function called the cumulative distribution where you can calculate all the values that are less than a particular value. So I want to calculate a bunch of values that are less than 11, but I only want to go up to 10. So the cumulative values from 0 to whatever number I have. And then now I want to subtract that from 1 by looking at these two numbers. So how would you do that on the graphing calculator? You would say 1 minus the binomial CDF of all the numbers up to 12 or up to 10. So let's go to second function in distributions. Let's look for the CDF this time, the cumulative distribution. N is equal to 12, P is equal to 0.8, and then this time I only want to go up to 10 because I'm not including 10, I'm not including 0 to 10, so that's the 1 minus, that's what that does, and then I'm only including from anything bigger than 10, and so that would be 11 and 12. So if I close the parentheses, hit enter, I'm going to get the same value that I got. That's 0.2748, and that's the answer that you got over here. So, okay, I hope that helps. Good luck.